Finish the card.
I mean, there are venomous snakes around here. You have copperheads, and there's rattlesnakes that you don't see very often.
You never seen one, at least around here.
It's cute.
I know.
You what?
No ALS.
Really?
At least I was young, so I could be wrong on that, but I'm pretty sure that we did.
Well, there was a report that came out that listed Mark Twain Lake as one of the rattlesnake hotspots in Missouri. So there you
I
go.
know we can read it. Well, we saw some things.
That's really, and then spiders. Recluses. Recluses.
Yeah.
That's good.
All right, domain. We know that in a fraction, the denominator can't be 0. So x squared can't be 4. So x can't be plus or minus 2. So domain, what x is, it's everything else. So negative infinity to negative 2, everything between negative 2 and 2, everything bigger than 2. Intercepts. So x-intercept is when y is equal to 0, so when this whole thing is equal to 0. And that just gives us 0. To find your y-intercept, you put in 0 for all the x's. So we get 0 over negative 4, which is 0. I told you could skip part C, the symmetry. Vertical asymptotes are x equals what makes the denominator 0, which we already found in A. So x equals plus and minus 2, or you can write them separately. To find the horizontal, we have to do the limit as x approaches positive and negative infinity of x over x squared minus 4. So if we take everything times 1 over x squared, the limit as x approaches plus and minus infinity of 1 over x over 1 minus 4 over x squared. So a number over infinity goes to 0, so we have 0 over 1 minus 0, which is 0. So horizontal, y equals 0. Then we need to do our derivative. So quotient rule. Low, d high is 1, minus high, derivative of the bottom is 2x, over low squared. So we get x squared minus 4 minus 2x squared. Or negative x squared minus 4 or x squared minus 4 squared. All right, so then critical points is when this is 0 or undefined. If you set it equal to 0, so that's when the top is 0, you get imaginary, so we don't have to worry about that. But we also have to worry about when it's undefined. So that's plus and minus 2. So my critical points are plus and minus 2. So then if we do our sign line, and we're putting those into this derivative, so I would get negative 9 minus 4, which is negative. The bottom is squared, so it's positive, so that section's negative. Put in a 0. 0 minus 4 is negative over a positive, so negative. Put in a 3, so a negative over a positive is still negative. So, can I just say it's decreasing from negative infinity to infinity? No, because we have asymptotes. So it's decreasing negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. Never increasing. All right, so far so good. Now, we need the second derivative. Oh, sorry, I didn't do max or mins, did I? Max and min. If it's always decreasing, we have to have a change to get a max or a min. So there's no switch, it's always decreasing, so no max or the second derivative. Low, d high, so the top would be a negative 2x, minus high, d low, so the 2 comes down, inside stays the same, subtract 1 from the power, so the first derivative of the inside is 2x, over low squared, so if it's already squared, when you square it again, it's to the 4th. Are we okay to this point? So now we want to try to simplify this mess. Look for any obvious simplification we can do. So what I see is this x squared minus 4 shows up a lot, so I can cancel 1 here, and 1 there. So now we get negative 2x cubed plus 8x. Here, I'm going to distribute my negative, my 2, and my 2x, so a negative 4x. So that would be plus 4x cubed plus 16x. Oops, so we get 2x cubed plus 24x. X squared minus 4 cubed. If you wanted, we could take a 2x out of the top. So our inflection points, anywhere this is 0 or undefined. Okay, if I set the top equal to 0, I get 0, but if you set x squared plus 12 equal to 0, that's imaginary, right? So we just get 0. And then when the bottom is 0, that's plus and minus 2. So our sign. Smaller than negative 2, between 0 and negative 2, between 0 and 2, and bigger than 2. Alright, and I'm plugging them in here. So if I put in negative 3, I get negative 6. That'll be a positive. 9 minus 4 is positive. So 2 positives and a negative would make a negative. If I put in negative 1, I get negative 2 times the positive divided by a negative. So that section's positive. Where I put in a 1, I have a positive times a positive divided by a negative, so that's negative. 3 positive times positive divided by a positive, so that's positive. So it is concave down, negative infinity to negative 2, and 0 to 2. Concave up from negative 2 to 0, and 2 to infinity. So if we plot x and y intercepts for both 0, vertical asymptote at positive 2, negative 2. Horizontal asymptote was 0. We don't have any maxes or mins to mark. My inflection points, the 2 and the negative 2 are at asymptotes. The 0, if you put 0 into the original, you get 0. So 0, 0 is also an inflection point. So we know this graph has to be decreasing. My options with asymptote, it could be up here, but that's increasing. Or it could be down here. So it's got to be down here for decreasing, and it's curving downward. So it looks like that. Still decreasing, so it has to be falling, but curved upward between negative 2 and 0. So it'll look like this. decreasing but curved downwards, so it's like the chair here. And final section, it has to be decreasing but curving upwards.